So today we're going to look at section 2A, which is entitled Working with Units. As I've stated before, I'm not going to go through this entire set of lecture notes, but I rather will try to hit the highlights and hopefully just give you a brief introduction to the material. And as you know, on Blackboard there's still a full worked out solution key that you can reference. Feel free, if I didn't answer all of your questions here in this video, to always call me or email me. Also touch base in the math lab. So we'll start here in the table. Per is a keyword for division. Of or a hyphen is a keyword for multiplication. When you see something being squared, that means raising it to the second power. And so a common unit that you would see there may be square yards, square feet. Cube is raising something to the third power. Sorry, my pen's not quite cooperating there. Raising it to the third power. I'm going to scoot on down here to example 1. In this first set of examples, some of you might think, why is she making this a little more maybe difficult than she has to? I want to show you this setup for units because I know that you're going to find that to be a helpful resource as we move through this unit. So I'm going to set these up using the idea of units, and you'll see as we go through this set of notes why I'm showing you this particular method here for these first couple of problems. So looking at number 1 here, it says find the total price that you would pay if you were to buy 20 apples at a price of $2 per apple. Always, ask yourself, okay, well, what am I trying to find here? And this problem is asking you for a total price, meaning the unit that you want to end up with then has to be money. So we know here then we are starting with our 20 apples. If you ever don't start with a fraction, make it a fraction by putting it over 1. And then this is a setup very similar to maybe a setup that maybe you would have seen in a chemistry class. At this point, I'm going off of what you hopefully would recall from working with fractions. When your units are diagonal, or whenever you had things that were in common with one another, as long as they were diagonal, you could cross them out. So in our case here, we want to get rid of apples and get to money. So if I want to get rid of those apples, since that apples unit is sitting up here on top, I'm going to move it down here to the bottom. And I know from my problem that I can go directly from apples to money with this conversion here. So I'm going to put my money up top, and I know that every one apple costs $2. That way, the apples have canceled out. I multiply straight across, and I have 20 times 2 up top, which gives you 40. On the bottom, you have 1 times 1, which is just 1. So, of course, then 40 divided by 1 gives us 40. The only unit you have left in the problem is money, so therefore that's the unit for your final answer. I'll let you try number 2 and number 3. I'll scoot on down to number 4. Here you have a room that's 10 feet by 12 feet. We want to know the area of that room. So obviously here you're given a length and a width, so it's a rectangular room. Formula for area of a rectangle is length times width. In our case here, our length then we'll say is 10 feet. We're going to multiply that times our 12 feet. Obviously then, 10 times 12 would give us 120. Then we think about, okay, well, what are the units on this? If you think about it, feet times feet gives you feet squared. So anytime you're talking about area is always square units, whether it's square feet, square yards. Volume is always cubic units. It could be cubic centimeters, and so forth, okay? You'll notice on your conversion sheet, which hopefully you would have definitely handy by this point, this is the conversion sheet. You'll notice that I got them arranged by length, weight, capacity, American units versus down here American and metric units. You will have this available to you when you take your test. This gives you a nice conversion between inches and feet, inches and yards, and so on and so forth. if you want to do a direct conversion, whenever I use the words direct conversion, can I take something from inches to feet? Because I have a line here on my screen that takes me from inches to feet, I would say that would be direct, okay? For example, though, if I wanted to know how many ounces were in a gallon, I don't have one that takes me directly from an ounce to a gallon. So I would have to take it from an ounce to a cup, then a cup to a pint to a quart, and then ultimately a quart to a gallon. So that would be what I consider not a direct conversion. All right, going back to the notes then, I'm going to look down here at example 1. It says you're traveling in Australia. Road sign says that Sydney is 24 kilometers away. I wonder how far that distance then is in miles. So I start with what I'm given, 24 kilometers. And I want to get rid of those kilometers, so I put kilometers on the bottom. And I ask myself, looking at my conversion sheet, can I go directly from kilometers to mile? And you'll look down at the bottom, and you can, towards the bottom I should say, and you'll notice that, and I'll bring it up for you, you'll notice that the conversion factor is right here. 1 mile is 1.6093 kilometers. You'll notice the 1.6093 is with the kilometers and the 1 is with your miles. It needs to stay that way when you do your conversion factor. So that since that 1.6093 is with the kilometers, I've got to put 1.6093 on the bottom and 1 mile up top. That way now, kilometers have canceled out. I'm left with the unit that I wanted because I wanted my distance in miles. So I can multiply now straight across. 24 times 1, of course, is 24. 1 times 1.6093, 1.6093. Do my division, and we're rounding it to the nearest tenth, so I would get 14.9 miles. Final answer. We'll move on to the next page. Look at example 3. So this is one that would not be a direct conversion. I can't do it in just one step like you just saw in the previous problem. It says you're making dessert for a large charity event. Oh no, excuse me. I want to go on down to example 4. How many seconds are there in 1 week? So let's start with 1 week. Again, it's not a fraction, so I'm going to put it over 1. I want to get rid of weeks. If you're like me, I don't know how many seconds there are in a week. I can't go there directly, but I can go from a week to a day. And we know that there are 7 days in 1 week. That way, at this point, weeks have canceled out. Okay? And this is, I'm going to keep on, because since I haven't gotten to seconds, I'm not going to stop. I call this a chain of conversions. I can't stop at days, so I want to get rid of days. Since days are up top, put days on the bottom. And I can go now from days probably to hours. And we know that there are 24 hours in 1 day. That way then days cancel out. Still not where I need to be, so I will continue on. I want to get rid of hours, so I put hours on the bottom, minutes up top. There are 60 minutes in an hour. We're getting closer. Hours have now canceled out. And then this next piece should do it for us. If I want to get rid of those minutes, I got to put it on the bottom so it'll cancel out to seconds. And we know that there are 60 seconds in 1 minute. That way then, minutes cancel out. In this case, we multiply straight across all the way up top, and you should get 604,800, and then the unit on that would be seconds, because as you notice, the only unit you had left at the very end was seconds. Okay, we'll move on down to example 7. This is a case where we have 2 sets of units. A slingshot projects an object at a rate of 5 miles per hour. I want to find this speed in feet per second. So far you've only worked with 1 unit, converting it to another particular unit. Here you are starting with 2 units and you are converting it to 2 different units. So what does that look like? So we start with our 5 miles. You never want to put more than 1 unit on top or bottom, so 5 miles for every 1 hour. Okay, so that's like 5 miles per hour. Remember, per was a keyword for division. you want to get rid of miles. So you put, and actually it doesn't matter whether we get rid of miles first or hours first. I'm just going to choose to go from our miles to our feet first. So if I want to get rid of miles, I put miles on the bottom. You look on your sheet, can you go directly from miles to feet? And I'm pretty sure up at the top you will see that you can do that. And your conversion sheet tells you that there are 5,280 feet in 1 mile. Since the 5280 is associated with the feet, the 5280 has to go up top where you've put feet in every 1 mile. That way then, miles have canceled out. You're left with feet up top, which is what we wanted. Okay. We now have to get to our seconds. This will be a little different. You'll notice that you've got to get rid of these hours. If hours are on the bottom and you want it to cancel out, then you've got to put hours on top. They've got to be diagonal from one another. You can go directly from hours to seconds, but it might be an easier process for me just to show you hours to minutes. And we know that there are 60 minutes in an hour. That way now hours have canceled out. I've got to go one more time because I need to get rid of those minutes and get to seconds. Again, minutes are on the bottom. If I want to cancel out, I've got to put minutes up top to seconds. We know that there are 60 seconds in 1 minute. That way now our minutes have canceled out. The only units I have left, feet up top, seconds on the bottom. So I've got exactly what I needed. I multiply straight across. Up top you get 26,400. On the bottom you get 3,600. Go ahead and do that division, and then you're rounding it to the nearest hundredth, so that's 2 decimal places. So that's going to put you at 77.33 units feet per second. Final answer. Okay. We'll go on to the next page. Let's look at example 8. This one encompasses a little something different here. The first part, not so much. We'll say it says for us to measure a classroom and express the length and width in feet. For ease here, I'm just going to say, let's just say our classroom is 20 feet by 30 feet. So our classroom here is 20 feet by 30 feet. And suppose the college wanted to carpet the classroom. We want to know how many square feet of carpet would they need. So square feet, then we're talking about area. So it's just a simple multiplication here. Area equals length times width, like we saw a few minutes ago. So I'll just put in our length of 20 times our width of 30. 20 times 30 is going to give us 600. And like we talked about a few minutes ago, feet times feet is going to give you square feet. So there's your units. And that's your answer to the first part there. So then the second part says, well, you get to that carpet store and you learn, well, carpet's only sold in square yards. So our problem here is then, okay, well, I know that I need 600 square feet. How can I convert those square feet into square yards? You say, well, I don't have that on my formula sheet. You actually do. We'll just have to manipulate it a little bit. So start with what you know. You have the 600 square feet. Again, it's not a fraction, so put it over 1. Always make it a fraction for yourself, okay? You know that you want to get rid of those square feet, so put the square feet at the bottom. And we know that we want to go to square yards. So really the only thing different is that you notice on your conversion sheet that you just have a conversion taking you from just normal feet to normal yards. And our issue here is, okay, well, we've now squared them. So what happens then is if we squared the units, we've got to square the conversion factor. So looking on your formula sheet, it tells you that there are 3 feet in 1 yard. So again, if the units here are squared, I've got to square this conversion factor, like so. That way now, my square feet have canceled out. I'm only left with square yards up top. And then up top you've got 600 times 1 squared, and of course 1 squared is still 1, so I just have 600 times 1, which is just 600. On the bottom I have 1 times 3 squared, and 3 squared is 9. Do my division, and I get 66. You get 0.666, since we're rounding to the hundredths, then that'd be 66.67. Our units then square yards. Okay? So you will definitely see that again. everything I'm talking through you'll see again, but just make sure you, if you need to, watch that part again. I'm going to scoot on down to the metric conversions. You'll notice on your formula sheet that it's given to you in two ways, either in a table or, as you see, also in a number line format there. A couple of things that I'll draw your attention to. You have a base unit, whether you are measuring